Okay, these are notes 4.3. We have a two-way tables and Venn diagrams we're going to talk about today. So we're going to talk about how to use a two-way table to find probabilities. We're going to calculate probabilities with the general rule. Then we're going to use the Venn diagram to also find probabilities. Okay. So we've talked about a general rule. Well, we talked about the or statements a little bit the other day. We said if events are mutually exclusive, okay, remember mutually exclusive events cannot happen at the same time. We said that you can't pick an M&M and have it both blue and yellow or orange or whatever. Okay, it can't be different. It's one color. You can't pick one that's both. Okay, so we had said if we want to find the probability of like the M&M being red or blue, we just take the red and the blue and we add those together. Okay, so we're going to talk more about today what if it's not mutually exclusive and how do we find that. Okay, here's kind of the idea. When you order in a restaurant and they ask you, do you want soup or salad? They wait and you want to choose one or the other. You don't get both. However, there's other times, like when you order coffee, they ask if you want cream or sugar. And then it's okay to ask, yes, I'll have one or the other, or I'll have both. Okay, so this is kind of the idea here when we go through it. So here's an example we'll look through. So students in a college stats class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender, so whether they're male or female, and then also whether they had their ears pierced or not. So yes or no if they had their ears pierced, and this was the data they collected. There's 178 people total, and here's our data. Okay, so we're going to define some events here. We're going to say that event A is getting a male student. Event B is a student with their ear pierced. Okay, so if I want to find the probability of A, okay, getting a male student. So the probability of getting a male student. So if you look at male students, they're 90 out of the 178 people. Okay, forget the probability of B, getting somebody with their ear pierced. Okay, out of a sample space of all the people, we have who has their ear pierced. So ear pierced, yes, would be 103 out of the 178. Okay, now we'll get a little bit more complicated here. Probability of A and B. Okay, so probability of getting a male student and having their ear pierced. So out of the 178 people, how many people are both male and have their ear pierced? Okay, male and ear pierced was 19 out of the 178. Okay, now this is where it gets a little bit different. Okay, A or B. So if it was mutually exclusive, it would mean that there's no males that have their ear pierced, right? They can't happen at the same time. Okay, but they do in this case. There are males with their ear pierced. So these are not mutually exclusive events. So I can't just take A and B and add those together, okay? Because if I did, let's think about that. If I take A and B and add them together, that would be 193 out of the 178. Now, that's a probability that's over 1, and we know that probability can't be over 1. Okay, so what's happened here? Okay, well, we've overcounted some people, right? Okay, so probability of A, this is one way to do it here. A would be 90 people. Well, I'll approach this way a little bit differently. Okay, A or B. So if they're A, they're male students, so we would use these people. And if they're B, their ears pierced, we used those people. Okay. Now, if I just take the 90 males plus the ears pierced, I got that 193, right? Now, what did I do there? What did I do? Why is it not really 193? Why can I not just add 90 and 103? Okay, the reason is because these 19 people, I counted twice. Okay, so one way to find A or B is to think about how many these people, or these people. So it would be 19 plus 84 plus 71. Okay, so if I add 19 plus 84 plus 71, I get 174 out of the 178 people. Okay, so 184 out of the 178 people would have their ears pierced. Okay, now another thing to look at is kind of a general rule. Well, we'll get to that in a second. Okay, another way to think about it is if it's A or B, the complement of that would be the ones that don't, right? So if I have 178 minus 4, that gives me the 174 as well. You could do it that way, okay? But our general rule is this. If they're mutually exclusive, okay, if they can't overlap at all, then it's just the probability of A plus the probability of B. Okay? Now, but if they are mutually exclusive, let's think about this here. I could think of this if they're not mutually exclusive, right? If they overlap, right? There's some males that have their ears pierced. We would say it's a probability of A plus the probability of B. Okay, so if I take A plus B, right? But then I have to think about, oh, I overlap some of these, right? These 19 I counted here and I counted there. Okay, so I don't want to count them in both groups. So I can subtract the probability of A and B. So if I think about this up here, I could take the probability of A, which is this, plus the probability of B, which is this. But then notice I don't want it to, I need to subtract those overlaps. So minus the 19, and that gives me my probability then. Okay? So here's your general rules. Well, this is really just a general rule, okay? But if you think about it, if it's mutually exclusive, we know the probability of A and B would equal 0. So that's why we're just kind of adding 0 there, right? Okay? Because things can't happen together. So the probability of A and B happening together would not happen at all. Okay? It's impossible if they're mutually exclusive, meaning they don't happen together. Okay? Okay, so here's a problem for us. So in 2014, a survey suggested that 71% of teenagers use Facebook, and 33% use Twitter, and 15% do both. Okay, so if we select a U.S. teen at random, what's the probability they're going to use Facebook or Twitter? Okay, so we can use F and T. We don't have to use an event A and B. Okay, so you just use whatever letters you want. So the probability of Facebook was 71%. The probability of Twitter was 33%. If I would just straight add those together, that'd be 104%, which would be over, right? But we've counted some people twice, right? The people that do both are counted in this one and this one, so I have to subtract them out, okay? I only want to count them once. I don't want to count them twice. So that minus that would give me an 89% probability, okay? Next thing we want to do is I want to take this data here and I want to put it into a Venn diagram. Okay, so let's say this is gender. Let's say this is male, and this is ear pierced. Okay, so we're going to take male and ear pierced. So I want you to pause the video and think about where you would put these numbers in here. Okay. Okay, so first of all, I like to start from the inside and come out. So this area in here means that they are both male and their ears are pierced. So male and ears are pierced are 19 people. Okay. Now in this circle, I want all the males. So I want a total of 90. Okay, total of 90 in here. But just in this section over here means that there are males without their ear pierced. So you can either think 90 minus the 19, or we know that was 71 people. Over here, I want those that are ears pierced. Okay, everyone with their ears pierced. So ears pierced was 103. So I need 103 people in here, but I don't want to count the males, okay, because the males would be in this category. So this would be the ears pierced without males, which would be the 84 people. Okay, out here, this is people that aren't males and aren't ears pierced, so that would be 4 people. Okay, so yeah, this is the people that aren't either of those. Okay, if you can think about this as well, in a Venn diagram, if this is event A, we had talked about the complement, right? The opposite of A. This would be a complement on the outside area. Okay, now let's talk about intersection versus union as well. Okay, intersection, we would say the intersection of A and B would be this, and the union would be this. Okay, I think U is union. Okay, U, union. Okay, and intersection would be upside down and upside down U. Okay, now the intersection, if you think about Venn diagrams here, intersection of A and B, well, it would be where both of them are together. So right here, right there is the intersection. Okay, so that's the A and B. Okay, something is both A and B right there. Okay, whereas the union, I kind of think of it as, I kind of explain it sometimes with, like, this is my wife's stuff when we got married, this is my stuff when we got married, right? So the union, when we bring it all together, would be all of our stuff together. Okay, some things I only had, like a football. Some things she only had, like, I don't know, hair dryer. Cause I really don't need hair dryers. Anyway, and then here would be all the stuff that we had in common. Okay, what we both had. We both had some pots and pans and stuff when we came together. Okay, so union versus intersection there. Okay, so let's think about this. If they're mutually exclusive, okay, what would the graph look like? Okay, if they're mutually exclusive, what would the graph look like? Okay, we know they can't happen together, right? So there would be no intersection. So we'd have event A and event B, and there's no overlap between them. Okay. Okay, so here's a problem for us. In a large apartment complex, 40% of residents read USA Today, 25% read the New York Times, 5% read both. Okay, so let's think about this A as a Venn diagram. Okay, so we'll say this is the USA Today, and they say some of them read both, so I'm going to have them overlapping, and this is the New York Times. Okay, so I'm going to start from the inside out. So it says that 5% read both, so I know 5% will read both. That's the intersection of them. Okay. It says only 25% read the Times. So if it doesn't say only read the Times, okay, those 25%, I know some of them read both of them, right? Okay, so if there's 25% in here of the New York Times and 5% are here, that means 20% would only read the New York Times. Okay, and then same with the other with USA Today. I know the whole total would be 40%, and if 5% read all of them, I know 35% would be over here, only the US Times. Okay, now if you add this all together, that would be 60%. Okay, so what would be out here? We would have 40% that don't read either of those. Okay, so part B, find the probability of a person reads exactly one of the two newspapers. Okay, so the probability of exactly one of the two. Okay, so that would be 35% of the people read only this one, and we'd have 20% of the people only read this one. So we know that 55% of the people would read only one magazine or newspaper. Okay, so that is our answer there. Okay, next one, who owns a home? So what is the relationship between educational achievement and home ownership? So a random sample of 500 adults was selected. Each member of the sample was identified as either a high school graduate, yes or no, and either a homeowner, yes or no. Okay, we have this table here. So here are some questions for us to answer. Okay, so suppose we choose a member at random. Define G as a high school graduate and H as a homeowner. So why does G or H not equal just to G plus H? Okay, so we know that some people, if it's not mutually exclusive, basically. So some people are graduates and homeowners. Okay, so I don't just have people that are graduates and just others that are homeowners, right? There's some overlap between those. Okay, so I have to use probability of graduates. Okay, so they're not mutually exclusive. So remember, I can take A plus B and subtract A and B. Okay, so probability of a graduate. So graduates, let's find out how many total graduates there are. So that would be 221 plus 89 gives you 310. I'll find all the totals here. Okay, and we knew there were 500 total people. Okay, so graduates, this is the probability of somebody being a graduate, right? 310 out of 500. Okay, so we added these two together here. Now the probability of somebody is a homeowner, okay, would be 340 out of the 500, which we added these two together. Now, notice we counted this group of people twice. We counted them here and we counted them there. So we have to subtract that group of people out. Okay, so if I take 310 plus 340 minus 221, whoops, I messed up. 310 plus 340 minus 221 gives me 429 people out of the 500 are either homeowners or graduates. Okay, so part B, make a Venn diagram to display the sample space. So there is some overlap to them. Some people are both. Okay, so that we'll have this be the graduates and these are the homeowners. Okay, so start from the inside out. These are the people that are graduates and homeowners. So yes and yes would be 221. These people over here, total homeowners, minus that, right? So these are the people that are homeowners with no graduate. Okay, so homeowner yes with no graduate would be 119. And over here, this out here would be the people that are graduates, but not the people that are homeowners, because those are in there, right? So these are graduates, yes, homeowner, no. And then out here would be not a graduate and not a homeowner, which would be 71 people. Okay, and then we want to write this in symbolic form, is not a high school graduate, but is a homeowner. Okay, so not a high school graduate, so we're outside of here, but is a homeowner would be this right here, right? Okay, so we want this right here. So we would say this is probability of only a homeowner. Okay, or you could say also probability of homeowner and not a graduate, so graduate complement. Okay, or actually we could say this. Okay, if we think about the union and intersection, right, we want both to be true, so it's the intersection of homeowner and complement of a graduate. Okay, so we worked with two-way tables to find probabilities. We calculated probabilities with the general rule. Okay, our general rule is this. For all or statements we use this, but just know that if if it is mutually exclusive, this is 0, right? So we're just basically subtracting 0 from it there. Okay? And then we also worked with Venn diagrams.